Hello everybody and welcome back to another visual pattern challenge. Here is our pattern today. Here's step 1, step 2, step 3. They've even given us step 4, and your challenge is to predict the number of apples in step 5. If you can do that, can you also predict the number in step 43? And can you write an equation that could be used to predict the number of apples in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. Okay, so we've got a bunch of apples here, and it looks to me like this is growing fairly slowly, fairly steadily. I'm going to guess, just by looking at this, that this is a linear pattern. In a linear pattern, the growth rate stays the same from step to step. And there's something a little funny visually about this pattern. It looks like on this one, we've added an apple here and then one here to make this. And then when we go to the next step, it looks like we add an apple here and then here. So we're adding 2 apples each step, just we're alternating the sides of each row that we do it on. So the pattern sort of looks mirror imaged a little bit, although bigger, each step. But that doesn't change the amount that it's growing by, which is really what the important thing is here. Let's go ahead and make a chart. Well, before we make a chart, let's predict step 5 because I think that's fairly easy. Every turn we're adding 1 to the top and 1 to the bottom. So here and here is what the next step in the pattern would look like. So let's see, what have we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I think step 5 has 13 apples. But let's go ahead and analyze the numbers here and see if that makes sense with the rest of it. So we'll make a chart with the step and the number of apples in each step. So in step 1, we've got 5 apples. In step 2, we've added 2, so that's 7. In 3, that's 9. In 4, that's 11. And in 5, we're saying 13. Now that makes sense, right? It's going up by 2 every time. So if we did the differences in each step, 7 minus 5, 9 minus 7, 11 minus 9, 13 minus 11. It's 2. The difference is 2 in every step. So we see this pattern of the odd numbers, 5, 7, 9, 11, 13. When you get that constant in the differences, that verifies that this is a linear pattern. And we can use the equation for a line, y equals mx plus b, to model that. And this m, the slope, is your rate of growth, how much it goes up every step. So in that case, this is 2. So y equals 2x. And then we just need to find whatever the b is, and we can do that by checking this part of the equation with the first step. So x represents the step number. So if we put in the step number for x, I'd get y equals 2 times 1. That would equal 2, but then there are 3 more in this step. So to make that work, we just add 3 and add 3 in our equation. So that should be our equation, but at this point you probably want to test it with a couple other steps. So in step 2, y equals 2 times 2 plus 3. That would be 4 plus 3 is 7. Yeah, that's how many there are there. How about in step 3, y equals 2 times step 3 plus 3, and that would be 6 plus 3 is 9. Yeah, so this is working out. Our equation is y equals 2x plus 3. Then, once we've got this equation, getting the number of apples in step 43 isn't too tough. We simply plug 43 in for the step number. So y equals 2 times 43 plus 3. And 2 times 43 is 86, plus 3 is 89. So it looks like there are 89 apples in step 43. Is that what you got? Did you get this equation? Let me know. Thanks, everybody.